Okay, so I'm going to show you how to do problems 22 and 23 using Excel from a homework. Now, what I did is I copied the problem 23 into Excel, okay, and I copied the regression equation right here. Here's my intercept and slope. Now, what I needed to do, I need to do a couple things to calculate my variations. I need to calculate my means, the distance of the original value, y value, from the mean of the y values. So that's this column right here, y minus m. I have my y value minus the absolute cell where the mean of the y values lives. Okay, remember, to get mean, it's average of the column. And I did that, pulled that all the way down. Now, because there's negatives in there, I need to square it. So that's what this column is. Okay, I have my y minus my means squared. Now, to find my explained variation, I need to find the distance between the predicted value and the mean. Well, the predicted value is made from my regression equation. I have my y-intercept with an absolute cell plus the slope times the x. Now remember, to get the absolute cell, you use the F4 key after you type in the cell. And I pulled that down, and I got my regression equation, my predicted values. Then I subtracted my predicted values, the mean from the predicted values, which is this column here, which is just y hat minus this mean, again with that as a absolute cell, the dollar signs. Now again, because I need to square it, I need to have, get rid of my negatives, I square everything and I add it up. And so this number right here, this this 39.4106, I'm going to paste right in here. And I have my first answer. That is my explained variation. Now, my unexplained variation is just the difference between the total variation and the explained variation. It's just easier to calculate those two than it is to calculate the other one, since I need this anyway. So I subtract this explained variation from my total variation, and I get my unexplained variation, which is this column, this number right here. And I paste it in. It's easier to copy and paste because I did this in a previous one already, and I kept typing the number in backwards, and so therefore it's just easier to do it this way. So the total variation is just the sum of those two values, explained and unexplained. So there they are. Now, my r squared, or coefficient of determination, is the percent of the explained variation over the ratio of the explained variation over the total variation, or this number here divided by this number here. And I calculated it to make sure that they were the same, and with my formula, because I can do correlation and then square it, but I wanted to, this shows just proves that I got the right number. So it is 0.1418. So, and now finally, my standard error of the estimate. That is calculated by taking my original value, subtracting off the predicted value. That's y minus y hat. That's this column right here, which is B2 minus E2. Then I have to square it because I have these positives and negatives, so I square it, each one of them, and add them up. Then I take that value and divide by the degrees of freedom, which is, the degrees of freedom in this case is n minus 2. I had 8 values. 8 minus 2 is 6. So when I divide this value here by this value here, I get that part of it. I then have to take the square root of it, because remember, I squared this, so I have to undo that. I have to take the square root of it, and that gives me this value here of 6.3059. And I just paste that in there, and I got it right. So that is how you do all of those problems. And I'm not going to worry about that, so try later. And that's the end of this video.